Hey y'all, Data Guy here. And today I want to talk about something that, kind of gets left unsaid or talked about in the explosion of AI. But it's the single idea that sits under semantic search, recommendation feeds, and almost every RAG system that you've ever heard about. And the idea is embeddings. And almost no one ever stops to explain what an embedding is before they, start using it in architecture diagrams. So that's what we're going to solve today. I want to give you everything you need to know about embeddings, how they're made, what they do, how to use them efficiently. Because at the end of the day, an embedding is just a list of numbers that represents the meaning of something, whether that's a word, a sentence, an image, or a product, in a way that a computer can compare. And that's the whole concept. So the reason king and queen feel related to you is something that we can now hand to a machine because we turn that relationship into numbers that it can measure. So if you've seen any of my other modeling videos, you're very familiar, right? We're going to take a fuzzy human concept and give it a structure that a machine can work with. So build this up from zero, right? And without further ado, let's get into it and figure out exactly how embeddings are made and what they're used for. So one of the biggest problems that you might think is a little bit silly is that a computer doesn't read, right? It doesn't know that a dog means a furry animal that barks. To a raw machine, dog is just 3 characters and cat is 3 different characters, and there's nothing in those letters that tells it that these two things are more alike than dog and helicopter, because computers can really only work with numbers. So if we want a machine to reason about meaning, step 1 is turning meaning into numbers. And the naive way that people tried first was to assign every word an ID, where dog is 1, cat is 2, helicopter is 3. But the issue is that those IDs carry no meaning, right? Cat being 2 doesn't make it sit between dog and helicopter in any useful sense. The numbers are just arbitrary labels, not descriptions. Embeddings do something a bit smarter. So instead of one arbitrary number per word, you give each word a very long list of numbers. So almost like 300 or even up to 1500 of them in a lot of modern models. And each number in that list is like a coordinate along some invisible axis of meaning. So you can think of it like a location. A city on a map needs 2 numbers, latitude and longitude, to pin it down. An embedding is the same idea, but with way more axes. So one axis might loosely track, is this animate or not? Another might track royalty, another might track gender. And you don't actually handpick these axes, the model learns them, but the effect is that every word lands at a specific point in this high dimensional space, and then words with similar meanings will end up landing near each other. And that's the mental model you want to hold on to, is that an embedding is a coordinate within space, right? And then meaning becomes a location in space. And once a meaning has a location, the door opens to the trick that's going to make all of this useful and actually allows us to make those comparisons and know that a dog is similar to a cat. So now, if meaning is able to be a location, then similar meanings are locations that are close together. Similarity becomes distance. Dog and puppy land near each other, and dog and invoice land far apart. And now you can measure how related two things are by measuring how close their embeddings sit in space. And then it gets better because geometry actually encodes relationships. So the famous example of take the embedding for king, subtract the embedding for man, add the embedding for women, and you land almost exactly on queen. And it's pretty wild if you think about that, right? You're actually adding and subtracting different meanings, right? The direction you travel to go from man to woman is roughly the same direction you travel to go from king to queen. And the model was never told what gender is. It just learned that relationship as a consistent direction in space from reading enormous amounts of text. And that relationship then gets baked into the arithmetic. Now, in practice, we don't usually measure straight line distance. We measure the angle between 2 vectors, the direction they point, using something called cosine similarity. And cosine similarity is just a number from -1 to 1 that says how close in meaning are these two things. 1 means basically identical, 0 means unrelated, negative means opposite. So why the angle and not the distance? It's because direction captures meaning much more clearly than magnitude does. So a long document and a short sentence about the same topic point the same way even if one vector is bigger. So don't overthink it. Cosine similarity is the ruler. You point it at 2 embeddings, you get a score, you just plug in those 2 numbers, and then higher means they're more related, lower means less related, and that single operation is the single engine under everything else around embeddings. So who's actually building and defining and creating these relationships, and where do these numbers actually come from? And who decides that king gets this specific list of 1,500 values? And the answer is an embedding model, right? Which is a neural network that's trained on a massive pile of text with a deceptively simple job, predict words from their context. So show it the cat sat on the blank millions of times across the internet, and it has to get good at guessing mat or floor or couch. And to do that well, it's forced to learn which words show up in similar contexts. So then words that are used the same way end up with similar embeddings, and meaning falls out of usage. And there's an old linguistics line for this: you shall know a word by the company it keeps. And that is pretty much exactly how these models learn, right? It's learning, hey, what words is this word typically used alongside? And the important part for you as a builder is you're never going to want to train one of these yourself. You can call an embedding model the same way you call any other API. You send a text, it sends it back, you back the vector. OpenAI, Cohere, Google, there's a ton of different open source models that do this, where you hand over a sentence and get back a list of numbers and you're done. So don't try and over-engineer this. And it also isn't only words. The same idea works for whole sentences and paragraphs, which is where you'll actually use most of the time. And it works for images too. So a photo of a beach and the phrase sunny coastline can land near each other. And that's actually multimodal embeddings. And that's how image search by text description actually works. If you've ever done like Google image search. And it's the same concept every time. You take a thing, turn it into a point in meaning space, and then the thing changes, but the idea doesn't actually change. And also something to note is that if you're using different embedding models, they'll actually generate different embeddings so they can't be used with each other, right? So it's important, if you decide on embedding, to use one model for all of your data so that all of your data can actually see each other and calculate the correct distances. So now that we understand, how embeddings are actually made, where do you actually use them, and how can you use them to, start paying your salary? Semantic search is the first one and probably the most popular one, where old keyword searches just match letters. So if you search car, you would actually miss the documents that say automobile. And so if you embed the query and embed your documents and find the ones whose vectors sit closest, now you're matching meaning instead of spelling. So how do I reset my password finds the article titled Recovering Account Access even with 0 shared words. Then there's also RAG retrieval, and this is a big one right now, where if you ask a chatbot a question about your company's private docs, it doesn't magically know them. Under the hood, it'll embed your question, search a pile of embedded document chunks for the closest matches, and then stuff those chunks into the prompt as context. And the retrieval and retrieval augmented generation is just an embedding similarity search. And that's the entire trick. So get that section, it's pretty much the core of RAG, right? Then there's also clustering and dedupe. If you embed a million support tickets and group the ones that sit next to each other and topics emerge, then without anyone actually tagging them, you can find out what people actually complain about by looking at those clusters, because the same move catches near duplicates. And so also the same move catches near duplicates, right? Two records that aren't textually identical but mean the same thing sit right on top of each other in space. So it's really easy to see, oh, okay, I got 20,000 copies of everyone complaining about how bad my sign-in flow is. I might want to figure out how to fix that sign-in flow. Then you also have recommendations, embed the article you just read, or embed everything else, serve up the nearest neighbors, right? And that's how you get things like more like this is literally just closest in meaning space, and a huge amount of you might also like, you see on Spotify or YouTube or in your shopping cart, is nearest neighbor search over embeddings. And notice the shape of every one of these. You turn things into vectors, then find the closest ones. So it's 5 different products, but it's really just one operation that's underpinning all of them. Now, before I wrap up and leave you, I do want to give you some tips that'll hopefully save you some pain, and these are mistakes that people make constantly when they start using embeddings. First is, and I just mentioned before, can compare embeddings from 2 different models. A vector from OpenAI's model and vector from Cohere's are going to live in completely different spaces. Numbers might even be the same length, but they're going to mean nothing to each other. If you embed your documents with one model and you query with another, your search results are going to be garbage and you're going to have no idea why. So pick one model, embed everything with it, and if you ever switch models, you re-embed all of it with no exceptions. Then 2, embeddings are terrible at exact matches. They capture meaning, not precise strings. So if someone searches for an order number, a SKU, an error code, or an exact product name, similarity search will happily hand back things that are semantically close but completely wrong. And so the fix is hybrid search. Run old school keyword matching alongside your vector search and blend the results, meaning that for the fuzzy stuff, exact matching for the precise stuff. Third, an embedding only knows what its model was trained on. Coin a new term next month, and then you use heavy internal company jargon, or you work in a niche that the model never saw, it won't have any idea those things are related. So the vector is a snapshot of the training data, and it goes stale, and this is where also bias can sneak in. If the training text carried a stereotype, the embeddings will actually carry it too, and that'll sit right there in the geometry. And then fourth, specific to RAG, chunk size will make or break you. If you embed a whole 40-page document as one vector and you get mush, an average of everything that loses nothing, that matches nothing well, But if you chop it into 3-word fragments, and each piece loses its context. So there's no perfect number, but you want to find somewhere in between where, a paragraph or a few hundred tokens is usually the sweet spot, and it's worth, testing and adjusting rather than guessing. And then a similar one to close is don't trust the raw score as a percentage. A cosine similarity of 0.8 is not 80% relevant. Scores are only meaningful relative to each other within the same model, so use them to rank, not to set some magic universal cutoff that you read about in a blog post. That's just not what they're there for. So to summarize, just kind of what I want to stick with is, hey, an embedding is meaning that's written as numbers. It's a list of coordinates that places a word, sentence, or image at a point in space where similar things sit close together. That's the definition. Memorize that one sentence, and you'll be ahead of most people that use this stuff. And you also sound smart in a lot of calls. And then similarity is distance, and you measure it with cosine similarity, a score for how close in meaning two things are. And those numbers come from an embedding model that's learned meaning by predicting context. For you, that's usually just an API call. Text in, vector out. And then for every big use case, whether it's semantic search, RAG retrieval, clustering, dedupe, recommendations, it's just the 2 steps wearing different outfits. You embed your things, then you find the nearest ones. And that's it. So I hope you enjoyed this video. I hope you learned something, and I hope you have a great rest of your day. Data Guy out.